Why do we manage stormwater? You don't want to dwell on this. I think most of us know why. A little bit of history here. At one point, stormwater management was simply collected and dumped. It wasn't regulated very much at all. It was considered to be a nuisance. It was put into an inlet in a drain and dumped or shuttled into the nearest waterway without any kind of management, treatment, volume control, peak management control, anything else. They found out certainly that didn't work, caused a host of problems, as you know. Next, they came along with detention ponds, and you'll see a lot of these around still. And basically, when I'll talk about, as we know, stormwater best management practices. There's a structural one. From that standpoint, years ago, they basically were unipurpose, just to collect that water, delay, as it says, detention or detain it for flood attenuation to lower peak flood levels. It didn't do really much of anything else. It didn't do the other things I call the big three, which is detention and for flood attenuation, filtration, and infiltration, which of course is volume control and quality control as well. We do all three of those nowadays. Again, the problem with these approaches is that they really fail to consider the range of impacts related to improper stormwater management. And I want to differentiate that between proper stormwater management. And I'll talk about this, that we certainly can grow, we certainly can have growth and development, and we can have effective stormwater management at the same time through these various methods. Of course, go through these very quickly. We're all familiar with them. Increased volumes of runoff to local streams, channel erosion, pollutants, a host of them carried in stormwater. As you know, in Pennsylvania, the #1 source of pollution to our waterways is polluted runoff, or as it's referred to, non-point source pollution. In-street habitat degradation, pretty much destroyed streams, loss of that habitat, loss of groundwater recharge and base flow, and so critical to water supplies and also, especially during periods of low flow, but also to the base flow, to maintain that base flow. As we all know that these aquifers are hydraulically connected to all our waterways. And when it's not raining, that's what keeps them flowing. And if you don't have that supply, that recharge, that should be in there, because you have so much impervious cover and you're just shuttling into a waterway, you lose all that water in your aquifers, and during periods of low flow, it can make it much, much worse. Clogged culverts, we all dealt with those, undercut roads, increased infrastructure and public expense, big one. Stormwater discharge, very quickly you can see from the charts here, based upon different land uses, how quickly the peak flows and discharges from any types and levels of storms. See from the charts here, certainly that the significant difference between forested areas, meadows, that sort of thing, natural areas, and developed areas. For example, you're looking at an increase almost 5 times of just runoff. 10% is versus 55% from a typical storm. This is tremendously significant. Pollutants carried in stormwater, you name it. Metals, all kinds of toxic metals, heavy metals from all various sources. Organic chemicals, pesticides, oil, gasoline, grease. Pretty much anything that can leak or rust off of an automobile. Pathogens, certainly viruses, bacteria, protozoa, from a number of sources. Nutrients, really big problem for eutrophication of our waterways. Nitrogen and phosphorus, the two big ones there. BOD, or biologic oxygen demand, of course, from all this organic material that's put into there, hydrocarbons, human and animal waste. It's taking away, robbing that needed dissolved oxygen for life in this stream. Pretty much suffocates it. Sediment, again, another big problem, sand, soil, silts, and salts. A lot of people have, streams are impacted by that, especially, of course, in the winter when we have a lot of inflow of salt and various other things. Here's some pictures. Some of you may recognize some of these. This is a result of improper or no stormwater management. You can see pretty much clogged drains, just totally horribly eroded streams, washed out areas. The one here I like, river unsafe, water unsafe to drink, no fishing, swimming, or other things, more erosion. Many of our streams, unfortunately, are like that picture down there, and it doesn't take much, depending on the nature of that watershed. You look at that, and you look at, anybody familiar with Clark's Creek? You look at Clark's Creek, that'll be dark brown. Clark's Creek at that point, with a similar amount of storm, will be a little turbid. Because, well, of course, most of the watershed is forested. But anyway, with proper stormwater management, that can look like Clark's Creek. A lot of work, but it can look like Clark's Creek. Here is something else, and I get a number of calls about this, as you can imagine, because one of the areas I work in certainly is stormwater management. And the one here, one of my favorites, is the house about ready to fall into the stream. And I actually get phone calls about this. You know, what can I do because the erosion has been exacerbated so tremendously, and my house is now going to be part of the stream. Roadways washed out. I think we can know about what happened in Hershey here last year, the floods. That's not from Hershey, but it looked pretty similar to the damage that was done out here from the large floods. Also here you see, I like this one down here, where you see a utility pole. That's about ready to fall over. And it's based because of that tremendous erosion that really, frankly, shouldn't be happening. Of course, increased flooding and the flood damages that go with it. And there's something to think about. As I mentioned, many of these slides show the difference between developed areas or developed watersheds, you know, where that water's coming from, and undeveloped conditions. And it seems to underscore the adverse impacts of development, which certainly can occur. Of course, much of this is based on historic history, really. And historically, we have not done a very good job of managing stormwater from development in the past. We can develop and effectively manage stormwater. And you'll notice that some things I'm going to repeat tonight because I think they're worthy of repeating, and that one is definitely worth repeating. Having learned about these impacts, now we're going to try to manage stormwater. And the things that our considerations in the current stormwater management are, and I think we're all familiar with this, volume of runoff, controlling that, rate of runoff, quality of that runoff, again, big three, impacts on the physical, chemical, and biological health of streams, receiving waters, various things like this. And some people, if you don't fish, you say, who cares? But you drink water. And a lot of water companies and a lot of water supply come from those streams. A lot. The water I drink comes from 2 streams in Cumberland County. Gentlemen here from my hometown, you might say, and do come from surface water sources. And of course, loss of groundwater. And even if you don't have a private well and you're a public system, many public systems have groundwater fields, and the majority of their water comes from groundwater. And if you don't provide that infiltration and you rob those aquifers during those critical times of recharge, what's going to happen when you have those low flow periods? What's going to happen? And they happen every year. You're going to have less water available to distribute to people for people's uses. And if you have a drought, it makes it quite a bit worse, obviously. We're talking about a little bit about best management practices. I think most of you are familiar with those. They are referred to as stormwater best management practices. They come in basically 2 different areas, structural and non-structural. Non-structural, you achieve through planning, various ordinances that you develop, and development practices. For example, I think we all heard of green development practice, say, in the design. In non-structural, what you do from the get-go is you put stormwater management right in the design. For example, one technique is to reduce as much impervious area as you can, or hard surfaces as you can, by reducing maybe lot size, using the natural environment that you have on that project to manage stormwater. The more of the natural area you can preserve when you put your development in, for example, the better off you're going to be, the less you might have to depend on structural methods. Structural methods, of course, are what they say, structure. They're installed structures such as rain gardens, infiltration areas, inlet filtration. There's one there, it's a rain garden that was installed in the farm show. You'll see some porous concrete there, porous asphalt. There are a host of them. Are you all familiar with the Pennsylvania Stormwater Management BMP manual? Well, you know there is a host of them. And of course, not one size fits all. There's so many options to choose from to meet your goals. And stormwater management regulations, the fun part. There are a lot of them, as we all know, and they affect us constantly. Federal regulations, EPA, Environmental Protection Agency. These are recent changes with incorporation of the, of course, we NPDES, National Pollution Discharge Elimination System, construction permits. They are tied in with Chapter 102 of the Pennsylvania Environmental Law. Chapter 102 deals with erosion and sedimentation control and management. The NPDES permits for construction permits and post-construction stormwater management are tied in with and mesh in with and implemented really through the state's Chapter 102 program. But yeah, again, post-construction stormwater management requirements. These were not these are fairly new. Again, they're implemented through the state's Chapter 102 program, which I'll talk about later. And of course, NPDES municipal separate storm sewer systems, or MS4 for short. And of course, we're in phase 2, which is the small municipal separate storm sewer systems, and that's pretty much what all of us are. State regulations, again, tie in with and mesh in with the federal requirements. Erosion sediment pollution control, which is again contained in Chapter 102 of Pennsylvania Environmental Regulations. Again, with the post-construction stormwater management requirements, again implemented through Chapter 102. And Act 167 stormwater management planning. And of course, local ordinances, you all. Of course, stormwater management and erosion and sedimentation pollution control. Now, that's going to vary significantly whether you have, or you're an MS4 community or not, whether you have a permit or not, whether you have an Act 167 stormwater management plan in your county, and also other factors that may be involved as well. But in Chapter 102, you still do have, no matter what county you're from, you still do have some requirements. Talk about NPDES permit elimination system, or NPDES, regulates point source discharges. Stormwater is considered to be a point source, and it's regulated under this. You can have, it's implemented again, as I mentioned, through Chapter 102. It includes post-construction stormwater management. It's part of that permit. Any land disturbance activity, development activity of an acre or greater must have a NPDES permit and which includes for post-construction stormwater management. There's a lot that goes with it. They have a general permit or an individual permit. The general permit is basically has 95% of the permits that we look at the Conservation District. I should mention that the Conservation District acts under contract from DEP. We manage or do the 102 permitting and NPS permitting in Dauphin County for Dauphin County permittees. So about 95% of ours are general, which has, of course, the general requirements. If you need an individual NPDES permit, or the permittee does for that project, there's a lot more that goes with it. You would have to get an individual permit if you're located in a special protection watershed. That means high quality watershed, they call exceptional value watershed, or an exceptional value wetland. If you affect existing water quality standards, if you affect, this project will affect threatened or endangered species, or has the potential for hazardous or toxic discharges. For example, if you were to take a brownfield, an old industrial site, that ground may be saturated with arsenic or something from that manufacturing process. So in that case, now you're going to develop it. Well, you might have that has the potential to release when you're developing of that toxic material. They need an individual permit, and there's quite a bit more that goes along with that requirements. And of course, NPDES permits for, as I mentioned before, municipal separate storm sewer systems, or MS4s. Also, Act 167, Pennsylvania law, Stormwater Management Act, requires counties to prepare stormwater management plans for watersheds, watershed-based within the county, and municipalities are required to adopt ordinances